So last time we did RC and RL circuits. And since
and just as a review, RCRL is resistor, capacitor, resistor,
inductor. That's it. And you'll notice that in every single one, in each of these cases, there's one energy storage element. And because there's one energy storage element, that means that it's first order. If it was an RCC circuit, it would be a second order. If it was an RLC circuit, it would be second order. And what we're talking about with order is what order of differential equation is required to solve this circuit. So this will just have a single RCRL will have a single first order differential equation that models it. And for those of you who haven't completed differential equations, don't worry about it because we're going to give you the solution to the differential equation. But just as something that I'm going to erase in a second so it doesn't clutter up the room, an example of a first order differential equation might be something like that the voltage across the capacitor, not double derivative, but single derivative, plus 2 times the voltage across the capacitor equals the driving function. And if we've got a DC source, it'll be a single number like this. And a second order circuit might look like VC double prime plus 2 VC prime minus 6 VC equals, and maybe if we had it driven by a sinusoidal source, it might be 2 cosine of 3t. And then we have to find the voltage across the capacitor. We have to find this function in time for the first order circuit such that its derivative plus 2 times the actual original function is equal to 3. But for now, we've got this great plug and chug equation. And the plug and chug, and that plug and chug equation is that for RC circuits, the voltage across the capacitor for time greater than 0 is equal to whatever that voltage is across that capacitor at infinity, plus the voltage across that capacitor at 0, minus the voltage across the capacitor at infinity, all times e to the minus t over tau. And for tau, it's equal to RC. Or for a RL circuit, it would be equal to L over R. And so let's just do that for our RL circuit. We're going to do the same thing, except instead of VC, we're going to write it as IL. Now, a fair point is, what if we're asked to find some current or voltage other than VC or IL? And KC, what would you say to someone who says, hey, what's the plug and chug equation to find the voltage across the resistor, say? What would you tell them?
You said the voltage for a resistor?
Yeah, these are the equations right here. These are the 2 critical equations we have to find the voltage across the capacitor in an RC circuit or the current through an inductor. And what if someone says, well, I want to find a different variable? Maybe it's a voltage across a resistor. Maybe it's a current through a resistor. Maybe it's a current through a capacitor or a voltage across an inductor or something else other than V sub C or I sub L. What would you say to someone who says, I want to see the equation for that?
You probably just take it from one of those equations right there.
Bingo. You tell them that their very first step is to solve, if for an RC circuit or RL, the very first step is to solve for the VC or IL. You got to do that first. After you do that, you can then, as a last step, solve for whatever else you're asked to find. But that first step has to be to solve for VC or IL.
Quick question.
Yeah.
Does that say infinity, like IL infinity, or does that say co?
I'm not sure which one you're talking about. If you're talking about this, that's
Yeah.
VC at infinity. And
Oh,
if you're
at
talking about
infinity.
this,
It's infinity.
IL
Okay.
at infinity. And this is VC at 0. This is IL at 0.
So just to clarify, no matter like what we're looking for, like let's say we're looking for like tau, we need to find VC or IL first.
No, you find tau separately. There's three things that you need to find here, right? If you've got an RC circuit, you want to find VC, you need to find VC of infinity, VC at 0, and you need to find tau. So those are three different things. And you'll remember from that sheet that I gave you, let me share that. Here we go. So you remember from this sheet that I gave you that there are these 5 steps you do. Number 1 is you draw it for time less than 0, specifically to find that initial condition, VC naught or IL naught. The second step is you draw it for time greater than 0, specifically to find tau. The third step is you draw it at infinity, specifically to find VC of infinity or IL of infinity. The fourth step is you plug it into that pre-made solution that I just wrote. And then the fifth step is to find whatever you're asked to find, which if you're lucky is VC or IL, but if you're not lucky, it's something else like a voltage across a resistor. And then you've got to do what Casey said, find VC or IL first, and then use your own understanding of electrical engineering, of really circuits 1, to figure out how, now that you know what VC or IL is, how to find everything else. Does that answer your question?
Yes, sir.
Good. Okay. Let's go back to the whiteboard. So if you really understand this plug and chug equation, and you understand that 5-step method I gave as a handout, and for those of you who are watching this video afterwards, I'll have that handout on the 5-step method of solving first order switched DC circuits on my webpage. You can really leave now. That's everything there is for the entire class.